Well, we've made it back from a long break, and we are getting right back into the math. Today is section 3.5. It's writing ratios and proportions. Now, there's a lot of sort of complicated things that I need to communicate to you today, but I promise that they're simple. There's just a lot of different stuff. It's very intuitive, but just listen to the different ways we're going to think about ratios and proportions. The essential question for today is, how do I use equation solving techniques to solve problems involving ratios and proportions? Now, you're probably thinking, okay, I know what equation solving techniques are. That's what I've been doing all chapter, right? But do I know what ratios and proportions are? Well, you do. I just need to remind you of them. Like, you've definitely learned this before, and I think you'll recognize what we're talking about as soon as we get into it. So a ratio is a comparison of part to part, whole to part, or part to whole. It can compare those three different things, and we'll look at an example. It'll make the definition make more sense. A proportion is an equation that involves two equal ratios. So we're going to have two of these guys, like part to part, or whole to part, or part to part, whatever. And we're just going to set them equal to each other. That's what a proportion is. So again, let's actually look at an example. I don't know how many of you watch football, like American football, but I really like it. The professional league is called the NFL. And in the NFL, teams play 16 games. That's it. Football is a very punishing sport. They can only play one game per week, and they only play 16 games in the season. So a couple of weeks ago, the Ravens, which is the team I used to root for, I don't watch them much anymore, but yeah, they're the team I would root for. They had 3 wins and 1 loss. So all I want to do at the beginning is I just want to write the following ratios. And again, it's just a comparison. So first of all, let's compare wins to losses. Well, that's easy, right? They had 3 wins and they had 1 loss. And you can write it this way with a little colon in the middle. We know that that colon kind of means like 2, sort of, like 3 wins to 1 loss. You can also write it as a fraction. Every ratio you can write as a fraction, which is really convenient. Let's talk about wins to games. So I know they had 3 wins. And the games, how many games have they played total here? Well, obviously it's 4 games total. So the ratio of wins to games is 3 to 4. And again, I could also write that as 3 over 4, a fraction. And then the ratio of losses to games would be 1 to 4. So I could also write that as 1 over 4. Now, remember in the last slide I said you could do like part to part or part to whole. This one is kind of like the part to part, because yeah, you can have wins, you can have losses. Those are kind of both parts of the total number of games. This one would be a part to whole comparison, because wins are a part of the number of games that they played, and the whole would be the total number of games that they played. So when I was talking about part to part and part to whole on that definition on the last slide, this is kind of what I was talking about. But just remember, a ratio, you're just comparing 2 things. It's easy. Now, so far we haven't really done any math, but here's what we can use ratios for, and here's where it starts to get really just kind of fun, and it can help us predict a lot of things. Ratios are used a lot in real life. So here's the first one. Assuming the Ravens go on winning at the same rate, how many wins can we expect them to have at the end of the 16-game season? So here's what I'm talking about. Right now, remember, they've played 4 games total. And they won 3 of those, and they lost 1. And I want to see if they go on winning at the same rate, yeah, how many games are they going to have won at the end of the 16-game season? So let's think about this. Let's look at the ratio of wins to total games that they've played. And right now we've said that they have won 3 and they've played 4. So they've won 3 out of the total of 4. Let's think about what would happen here. Let's say they've played 8 games. Like, eventually they'll get to that point in the season. If they've played twice as many games, wouldn't you expect them to have won twice as many right? Like if they're winning at the same rate, if they've played 8 now, wouldn't you expect them to have won 6? Because they've won double the games, shouldn't they have double the wins? So here's the nice thing about ratios. They work like fractions. I can scale them up, I can reduce them down. As long as I'm multiplying the top and the bottom by the same thing, I'm good to go. So let's think about what it would take, how many wins they would have when they got to 16 games. So if they've played 4 times as many games, wouldn't you say that they should have 4 times as many wins? So shouldn't they have 12 wins? And so here is my answer, 12 wins. And all I did was I scaled the ratio. If they've played 4 times as many games, 16 is compared with 4, they should have 4 times as many wins, 12 as compared with 3. So ratios, nice. We can scale them up, we can scale them down, just like with fractions. You might see a different sort of problem, and that is this. The book's going to ask you things like 5 is to 7 as A is to 49. And we'll talk about what that means, but here's your example with words. Here's a sport that probably a lot of you watch more, and that is football, as in not American football, association football, world football. So Messi is to FC Barcelona as blank is to Real Madrid. Do you see what I'm getting at here? Like Messi is kind of the, well, yeah, he's like the best player on Barcelona's team. Whoops. So who's the best player on Real Madrid's team? Well, that would obviously be Cristiano Ronaldo. And I'm glad I'm putting this in a video, because if I say this in class, it tends to get into big debates, and I don't want to deal with that right now. So just know that these are how proportions can kind of be used in words. So how it applies to the math is this. I know that 5 is to 7 as A is to 49. In other words, I have this ratio, 5 over 7. And they're saying, okay, I have this other ratio, and it is equal to the first ratio. Just like with the words, Messi is Barcelona's best player, Ronaldo is Real Madrid's best player. Here, I have this ratio, 5 is to 7, and it's going to be in the same ratio, or it's going to have like the same rate as A is to 49. So I can write it like an equation, and this is called a proportion because it is 2 ratios set equal to each other. Now there are a couple different ways of solving this problem. First of all, I can solve it like I did on the last slide. Remember, ratios are just like fractions. In the math world, they work like fractions. Like I can use the same fraction rules as them. So let's think about this. If I'm looking at this fraction and kind of scaling it up, what would it take to scale the denominator of 7 up to 49? Isn't that going to be multiplying by 7? So if I multiply the denominator by 7, shouldn't I also be multiplying the top by 7? And remember, this is exactly what we did on the last slide to see how many games the Ravens will win in the end of the season. So yeah, let's multiply the numerator by 7 to find what A would be. Shouldn't A be 35? Because remember, I said ratios work like fractions. I'm just scaling it the same. Here's a different way of doing it though, and we should end up at an A of 35, but here's way 2 of doing it. This looks like an equation to you, right? And so I want to figure out, how can I get the variable by itself? How can I get just A over here by itself? Well, ignoring this side for now, what's messing with the A? Oh, it's being divided by 49. And how do I cancel dividing by 49? I need to multiply by 49. That will cancel the 49s and leave me with A. On the other side, then, I have to do the same thing. Let's multiply by 49. You know that that's like multiplying by 49 over 1. I can do some pre-reducing. 49 and 7 reduce, leaving me with 7 over 1. And I have 7 times 5, which is 35. Notice I arrived at the exact same answer. Solving a proportion like an equation is very helpful. So let's look at our last example. And in this last example, I could think of it like scaling. So like, how does 50 scale up to 60? What would I need to multiply 50 by to get 60? But that's not an easy scaling. I don't really know what I should multiply by. So instead, let's treat this like an equation. If I need to get the r by itself, what do I need to do? I need to multiply by 60. That'll cancel the 60s and leave me with just r. But if I do that to one side, of course, I need to do that to the other side as well. And let's do some pre-reducing here. I know that, first of all, let's look at this fraction. If I have 40 over 50, isn't that going to reduce to 4 over 5? Like I divided the top and the bottom by 10. And now let's look at some other pre-reducing. Oh, look, 60 and 5, that reduces to 12 and 1. I'm left with just 4 times 12. Both are in the numerator, and 4 times 12 is 48. And remember, that's like 48 over 1, but that reduces to 48. Awesome, so r equals 48. And I did it by solving it like an equation. So here's your summary. When you're solving proportions, remember proportions are two ratios set equal to each other. When you're solving them, remember you can solve them by scaling. So see like, okay, I can multiply this by say 2, so I'm going to multiply the top by 2 as well. You can solve it by scaling like we did in the first two examples, or you could think about solving it like an equation, just like we did in the last slide. Multiply to cancel out the division. Thanks for watching, guys. Sorry for the length of this video. It's a little bit long, but you made it to the end, so give yourself a pat on the back. You are an excellent student. Yay. Bye-bye.